Okay, so in this advanced lesson, week 6, part 1, what we're doing is just going through some review problems. So the first question is find the 413th number in the following sequence. Well, if you notice, this sequence is made up of the first 8 odd numbers. And so it repeats itself every 8. And so this is a modular problem. Essentially, we want to find out what is 413 is equivalent to what mod 8. Well, the easiest way to do that, since x is just going to be the residue, which means the remainder when 413 is divisible by 8, you divide by 8, you get 51, remainder 5. Well, the fifth term in our sequence is 9, and so the 413th term is also 9, and so the answer to this question is 9. 2 says, what is the remainder when 7 to the 312 is divided by 12? Well, you got to go through and look for a pattern. And so 7, and we're going to do it all this mod 12 because we're dividing by 12. Well, 7 is just equivalent to 7 mod 12. 7 squared, or 49. Well, 49 mod 12 is just equivalent to 1 mod 12. And whenever you find a 1 mod 12, that can be very beneficial because 1 mod 12 raised to any power is just 1. So we can rewrite this as 7 squared raised to the 156th power, right? Because 2 times 156 equals 7 to the 312. Well, 712 is just equal to 1 mod 12 to the 156, but 1 to the 156th power is just 1. So the remainder when 7 to the 312 is divided by 12 is just 1. Because 1, when you take that out mod 12, you get 1, which is always what the remainder is. 3, similar type problem, except this one's a little different, and this one's actually similar to the last one, but even easier. 22 is just equivalent to, negative 1 mod 23, right? 22 mod 23 is the same as negative 1 mod 23. Just subtract 3 from 22. Well, if you place that then, if we want to say, well, we're going to raise that to the 573, that is going to give you negative 1, right? Because a negative 1 to an odd power just gives you a negative 1. And so our remainder is equivalent to negative 1 mod oh, we did that backwards. So let's go back and correct ourselves. We did it backwards. We're dividing by 22, so 23 is equivalent to 1 mod 22, and whenever that's the case, that means that every time you go through and do this multiplication, you're going to get a remainder of 1 no matter what this power is, so the answer to this question is just 1. This is the one that we just did the same thing of. 16 is equivalent to negative 1 mod 17. So if you raise that to the 542nd power, you find out that that just equals a positive 1. So the remainder when 16 to the 542 is divided by 17 is just 1. And that's because negative 1 is raised to the 542nd is 1. So one of the things, when you do these remainder problems, what you're looking for is you want to find out a 1 mod 22 or a negative 1 mod 16 or something that is you can raise, either one of those you can raise to a power and actually know the answer on. Okay, so the next problem we're going to do is how many 3-digit numbers are equivalent to 12 mod 17? Well, that means that you have to understand that 12 mod 17 is just a pattern, and that pattern is 12, and then you add 17 to it, 29, and you keep adding 17, so 46, and so on. So we need to find out what is the smallest 3-digit number that's equivalent to 12 mod 17. Well, 17 times 5 is 85, so that gives you 97. 17 times 6 is 102, so the smallest is going to be 114. And then that's going to keep going. Now we need the biggest, so I need something that I can multiply by 17 that gets me something close to 1,000. And so we could try something like 55. 55 times 17 gives me 935, which isn't quite enough, so the next one would be 952, 969, 986. 986 is divisible by 17, so that means that 998 is equivalent to 12 mod 17. Just add 12 to a multiple of 17. So how many three-digit numbers are there? Well, just do your nice formula. 998 minus 114 divided by 17 plus 1. And so that gives you 17. We're going to divide into 884. And it's going to go into it, well, 17 times 5 is 85. 34, it's going to go into it 52 times, add 1, and that means there are 53 numbers in this sequence from 114 to 998, which encompasses all the three-digit numbers that are equivalent to 12 mod 17.